welcome to my channel, and here we want to work on this problem which has to do with a triangular pyramid, the surface development of a triangular pyramid. And this triangular pyramid is a truncated one, in the sense that it's cut, this part is cut off, and these views are given in first angle orthographic projection. It means that this is the front elevation and this is the plan, as you can see it here. And let's talk about the dimensions on these views. For the front elevation, so we have the distance from here to the apex here to be 64, and distance from this base to this point where the curtains start down here is 20 millimeters. And then coming to the plan, we have that the length of side of the triangular base of the pyramid is 76 millimeters. That is all sides, as we have 76 all sides. So distance from here to here is 76, from here to here is 76, and from here to here is 76. Then the distance between this center point, or this point, from this horizontal line is 28 millimeters. And then the seam, so where we are to open from, is this AA that we have here, is a joint line, that is the seam. So we are going to make use of these dimensions to produce the front elevation and also the plan. Then we go on and produce the surface development of this triangular pyramid. So let us start. Okay, so the first that we are going to do is that I'm going to construct the plan. That's where I'm going to start from. I'm going to construct the plan, and to do that, I first of all draw horizontal line around here. Then drawing this horizontal line, I'm going to take a measurement. I'm going to draw a vertical line first. So I will draw a vertical line around this part here. So drawing a vertical line down, then I will take a measurement of 28 millimeters, 28 millimeters from this point on the line. So this is 28 millimeters here. So with this 28 millimeters, I have to be checking the work. So I'm going to draw a horizontal line. So I'm going to draw a horizontal line like this. Okay, then with this horizontal line that I've drawn, so the next thing that I'm going to do is that so I'm going to take a measurement of 76 millimeters on this line, 76 millimeters on this line, 76 millimeters on this line. This is 76 millimeters, 76 millimeters, and half of 76 is 30. That's 38. So 38 millimeters. This is where we have 38 millimeters. So I'm going to draw a vertical line here. Here I will draw a vertical line down. Okay, so it's really a technical work, so we need to take our time to analyze it. So we draw a vertical line down here. Then I'm going to connect this point. So this point now that we have here is point A here. So we have point A at this point. So this is point A. So I'm going to connect this point. I'm going to connect it together with this point. So we connect these 2 points together like this. Okay, so this line that I drew, so it is the line that we have here. So this is the line. So I mean this line, this vertical line that we have here, that is the line that we have there. So okay, so that's vertical line. Then we have gotten this line from here to here, from this point A to this end. So we have gotten this line. So the next one that we are going to get is that we are going to looking at what we have here. So I believe you know that this shape that we have down here is an equilateral triangle. Is an equilateral triangle. So all sides are equal, as we are told that 76 all sides. So it's an equilateral triangle. So which means that which means from this point. So if I take a measurement of I'm looking at it. So okay. So we have taken 76 from here to here, 76 millimeters from here to here. Okay, so that is one of the sides. So the other side, okay, so this is what I'm going to do. That means I need to make use of my my set square. So my compass. So I will take a measurement of 76 millimeters from here. So 76 millimeters from here. Then I will put at this point, and then I will make an arc on this line. So the distance from this point to this point will be 76 if you take the measurement. So if I take the measurement, so this is it. So this is it. Okay, so as we have it here, so this is 76 millimeters. If you look at it very well, it's 76 millimeters. So if I drop from here to here, so I have that 76 millimeters. Then if I join from here to here, join from this point to this point, so I will have that same 76 millimeters as we are given. So which means that so I will now join this point. So I will connect this point together with this point like this. But with what we have here, so we are not done. We have not drawn the plan of the truncated triangular pyramid. We have not drawn it because a part of it is truncated, which we need to show here in the plan. So we are going to do that or work that out right now. So what we need to do now is to go and produce the front elevations, to go and produce the front elevation of the triangular pyramid. So what I'm going to do here now, I'm going to extend this line, this vertical line. So I will take it up here like this. Then I move up a little bit. I will draw horizontal line like this. Okay, so from this point, so I'm going to draw a vertical line to meet this line like this. And here also I will draw a vertical line to meet this line. Okay, then I will take a measurement of 64 millimeters, which is the height of the triangular pyramid, 64 millimeters. So this is 64 millimeters. So which means I will now connect this point. So I'll connect this point together with the apex, and I'll also connect this point together with the apex like this. Okay, so the next thing that we are going to do is that we need to take the measurement of the truncated part, so which is 20 millimeters from the base here. So I will take a measurement of 20 millimeters here on this line. This is 20 millimeters. So this is 20 millimeters. So we have 20 millimeters here. So I need to locate this point on this land side here. So I'll just mark it here like this. Then so as we have in the drawing, so this point is connected to this point like this. So this part is cut off, so we can make it a thick line at once like this. Okay, so now, so this is a corner, so which means this line should be drawn with a thick line. So this line should be drawn with a thick line, so we make this a thick line like this. And also, so this line should be drawn with a thick line. Okay, so this is a corner, so it should be drawn with a thick line. And then this is also a corner, so we also need to make this a thick line. Okay, all right. So then so when this part is cut off, it means that this line will be shortened, and also this line also will be shortened aside this one. This one is just complete because the cutting plane is only cut this part off. So it will only affect the distance that we have along this line. So, and also the one that we have along this line based on what we have here. But so what I'm going to do is that I'm going to label it according to the way it is labeled in the drawing. So they said that this point is O1, and this is also, we have this to be A1, and then we have this point to be S1, so we have this point to be C1, then we have this point to be, so this is B1, and then this point is R1. Okay, so this point is R1 as we have here. So now, so let's get this part that is cut off, let us get it here on this line. So by the time I set my set square at this point, so if I draw a vertical line down here, it meets this point. So this point that we have here, so this point is point, so I call this point, so this is point R2. So R2, okay. So and this point that we have here, so I'm going to call it point O2. That is this point here. So this is point O2 here. And also, so we have this point to the point A2, and this point that we have here. So then we need to locate point S and point C. So this is point C. So this is point C2, while this point is point B2. Okay, so we need to locate this point S on this line. So how can we do that? So what we need to do is that we take the measurement, the distance from here to here. That is from C to S, or from S to C, like this. Okay, so I put it at point C here, and I make an arc here on this line. So this point is point S2. This is point S2 here. So now, so we can now make bring out the part that we need here. So by the time I'm going to connect this point together. So this point R2S2. So we connect them together like this. Okay, so we connect that together, and then point R2 and A2 will be connected together, or A2R2 will be connected together like this. So you are just drawing the plan. So what we did before is just a sketch, or just a complete the plan for the complete triangular pyramid. If it is not truncated, but since it is truncated, we have to cut off the part that is cut off in the front elevation. So that's what I'm doing now. Also, I'm going to connect this point S2 A2 will be connected together like this. Okay, so then these lines, so this line, so these are the edges that we have left for this particular truncated triangular pyramid. Okay, so we make this line, we're going to make it a thick line, and also this line from here to here, so we make it a thick line. All right, so now, so what we have left is to go on and produce the surface development. But before we do that, we need to find the true length, because if you look at what we have here, so these sides have been shortened, so we need to find the true length of So that's what we are going to do next. So now, to find the true length, so we are going to find the true length for two parts here. So we are going to find the true length of OA and OB. So also we need to find the true length of OC. So just look at how I'm going to do it. So the first thing I'm going to do is that I need to extend this line. I don't know how long it should be, but I'll just make it extend it like this. Then, and coming to the center here, I will also extend this line. Okay, so now I will take my compass and put it at this point O here, and I will extend it to B. Look at this line, this horizontal line. It contains both A2 and B2. So I can only make use of one of them. So if I put the midpoint of my compass at point O2 here and extend to B2, so I need to turn it down like this. So wherever it made this horizontal line, so I'm going to draw a vertical line up. At this point, I will draw a vertical line like this to meet this line. So then I'm going to connect this point here, connect it with point O1 here, like this. So this true length that we have here, it is the true length for this true length. So this true length is for OA, so and OB. So this is the true length for OA and OB. Then to get that of OC, so what I need to do is that I will still put the pinpoint of my compass here along this line and extend it to point C, and extend to point C. So you can see that when I'm to draw the true length, or to get this point OC, I have to compress this compass. That means the distance from here to here is not the same as distance from here to here. So that is what we are doing. So by the time I extend it to this point here, so that is point C2. So I will draw an arc. So the arc goes like this. So it made this point. So from this point now, I'm going to draw a vertical line. So I'll draw a vertical line from this point. I think it made this point, this line OS at this point. So I don't really, sorry. So it made this line OB. So which means that this is the true length. So this line, so is the true length of OC. This is true line of OC. So true length of OC. So and also it's also the same as the true length of OS. So let's take note of that. Okay, so now the next thing that we are going to do is to carry out the surface development. So true length. Okay. All right. So let's look at how the surface development will go. So let's look at it. Okay. So at this point, I'm going to draw a horizontal line. From this point, I will draw a horizontal line like this. Okay, so this point is going to be my point O for the surface development. So now I will take my compass and take the longest true length. So the longest true length is this O. This line, the true length of OA and OB. So this is the longest true length. So I put in point on my compass here at point O. Then I'm going to draw an arc like this. So I pray that this will be enough. I'm not sure if it will be enough for the work that I want to do. But just let me look at how I'm going to get it done. So now, what we need to do is to take for this point. So this point is point B. So this is point B. So what the next thing I'm going to do is that I need to locate this point R, because we are opening it. This is where we have the seam. So we are cutting it from here. So we take it from here. So I take the distance to locate this point R here. So I will take this distance, then putting it at point O. Then I will make an arc here. So this point is point R. So this is point R. So the next thing that I'm going to do is to locate point A. So is to locate point A. So how can I do that? So what I need to do is that I need to take a measurement of this 76 millimeters. I'll take it here like this from the base. Okay, so from the base I will take it, and then putting it at this point, I will make an arc here like this. So with this arc that I made at this point, we are using the length of the base. So very, very important, we have to use it. So because this is where we have point A, so we have to use the length of the base to locate this point. So, and then I will join this together. So join this together from here to here like this. Okay, so then the next thing that I'm going to do is to locate, so point S. We need to locate point S here. We need to locate point S. So how can we locate point S? So we need to locate point S. So this point S is what we need. So we don't need point C. So it's on C that we have what? Okay, I can even locate point. If I want to look, I can locate point C. So with the same word, with the same 76, I'll just put it at this point and make an arc here. So this is point C here. But on this point C, so I need to connect this point O A together. So this is point A, sorry. So this is point A. So I need to connect OA together. So if I connect OA together like this, so this is OA. So connect this OA together, and I'll also connect OC together like this. Okay. Then on this OC, I need to find point S. I need to find point S. So to get point S, so what I need to do is that I will draw a horizontal line from this point to the true length here. That is the true length. This one, that's what we are using. So I just take my compass from point O to this point here. So taking this distance, so I put it at point O here, and I will make an arc on this line. So this is point S here. So this is point S. So I will join this together. So I'll join this together. So that is AS. Connect them together. As you can see here that A is connected with S. So we connect these together like this. So next thing I'm going to do is to locate point B, which is this point here. To locate point B, which is this point. Don't forget that this arc that we have here, we use the true length of OB to draw, which is also the same as that of OA. Okay, so to get that, so I still need this 76 millimeters. So let me just take it along this line here. So I'll take it like this. So then putting it at this point C here, so I will make an arc here. I have to add a part to this part. So this point is point B. So this point is point B. So I'm going to connect OB together. I'll connect OB together like this. Alright, so that's OB. Then so the next one that we are going to locate is point R, which is this point, because S is connected with point R here. So we need to, as we have here, S is connected with point R. We also have it in the front elevation. So I need to come here. So this point R that we have here, this is the point. So as we have OR here, so we also have OR on this part. So they'll be of equal length. So all I need to do is to, so just let me take it from here. So putting the pinpoint of our compass at O here, and I will extend it to R here. So I'll just cut it here. So make an arc here on line OB. So then we are connecting these together. So we connect RS together. So this is point R. So we connect RS together. So all I need to do now is that I will make this line a thick line. So this line a thick line, and I'll make this line a thick line. So I'm going to leave this one like this because they are fold lines, or I can just make it with so line like this. So they are fold lines, so we are not going to make them thick lines. These are known as fold lines. Okay, so this is how the surface development will look. As simple as I've done it here. All you need to do is to practice. When you practice it, you become a master at it. Thank you, and God bless you.